Coil on plug ignition system testing. When performing any ignition analysis on a coil on plug, you're going to have to use a coil on plug setup. So make sure that you see, read, and understand the instructions for your equipment. Each coil on plug has a 2-wire connector. B+ from the ASD relay is shared by all ignition coils. There's a splice for B+ and separate grounds that go to the PCM for each coil. If output is weak on coil numbers 1, 3, and 5 as an example, you would suspect splice 111 here. As you can see, that's the splice that feeds B+ to those 3 coils. And the same holds true for coil numbers 2, 4, and 6. In this case, you would suspect splice number 109. Ignition control signals go to each individual coil from the PCM coil driver. So there's a wire that runs from each coil to the PCM, and that's the coil driver. The PCM coil driver supplies the ground for that coil. Let's look at the test connections for primary amps and voltage. You can see in the top waveform there we have primary amps. In the bottom waveform we have primary voltage. When looking at primary current, connect the low current amp probe to either side of the coil. It's a simple circuit, and you go to either side of the circuit, either side of the device, the coil, to get your waveform. In this case, we're showing you that the low current probe on the right there is away from the coil themselves. You can connect it right to the coil up there, either on the green or the tan wire, it doesn't matter. But when you use it away from the coils, your low current probe will pick up less noise and your waveform will be cleaner. Now, when you want to do ignition primary voltage, you're going to look at the ignition control wire. In this case, on this example, it's a tan wire. Connect the negative lead of your lab scope to a good engine ground, and then probe the pin on the primary voltage circuit. In this case, the tan wire. It's the ignition control side. Special note here, this is a technical bulletin, and it basically says do not run or crank the engine over with the ignition coil or coils removed from the spark plugs on any next generation controller. If any of the coils short the ground, damage can occur, and you can take out the PCM as well as the coil. So this is a very important technical bulletin. Let's look at these waveforms that we just went through and connected for. At the top there we see the ignition coil primary, and that's where we back probe the tan and the orange wire, the control side of the coil. On the bottom waveform we're looking at ignition primary current, and that's where we use the low current probe. Now in number 1 down there on the left, that's where the coil primary current is turned on. On the top waveform you can see that's where dwell begins and voltage goes low, and on the bottom pattern you can see that's where the current begins to ramp for the coil. Now we have different types of coils like with other manufacturers. The bottom waveform is a peak and hold coil. It demonstrates that the current ramps up and then holds before it fires. We'll show you a different one in a minute. Now on the right side you can see that the ignition coil primary current is turned off, and that's when the spark plug fires. And in the red box down there it's telling you to take note of the clean release of the coil primary, and that's creating a good primary kick. We don't see a lot of noise down there. Now this is a ramp and fire type coil. Whether you have a ramp and fire or you have a peak and hold type coil, what you want to do when you get your waveform up there is measure peak amps, measure the rise time. We're going to do that in testing in just a minute. Now, when you're looking at ignition coil primary current, this is a good example. You can see that we have a good burn time and we have a good firing line. Peak amps should be about 5 amps on this example that we're showing you here. Always use vehicle-specific specifications. Low amps, low current, can be caused by low B+ to the coil, or a bad coil. And it could also be caused by high primary resistance. Those are the things you would look at if you had low peak amps. If peak amps are lower than normal, test the coils B+. It should be within a half a volt of B+, system voltage. Next, test the PCM's grounds. They should be less than 50 millivolts. If B+ and grounds are normal with low primary current output, check the coil's primary resistance. Measure the primary resistance of each coil between the ignition and the ground terminals on each coil. Compare the resistance of the bad coils to the good coils and find the one that's not normal. You will now be returned to the test selection menu. Make a selection based on your test results.